a shift in the Earth's inner core that sounds like the plot.
They're spinning backwards. I mean, this is worse than having a tsunami or an earthquake. The stability of what you walk on is at stake.
Scientists have issued what some are calling a red alert regarding a dramatic shift in the planet's magnetic behavior, the kind of deep time upheaval that keeps geophysicists awake at night. The planet we walk on, breathe on, and navigate through is quietly revealing signs that its magnetic shield is weakening, wobbling, and possibly preparing for an extraordinary event, a reversal of our magnetic field. The implications are sprawling, profound, and terrifying in their slow, inevitable unfolding. Before we start, smash the like and subscribe buttons for more updates. The magnetic field that envelops Earth is generated by the roiling motion of molten iron and nickel in the outer core, which creates electric currents and thus a vast geomagnetic field reaching far out into space. It acts as a protective shield, deflecting charged solar particles and cosmic rays, preserving both atmosphere and life on the surface. Over millions of years, this shield has not remained static. It has faded, fluctuated, and in the distant past, reversed entirely, such that magnetic north and south trade places. That such reversals have occurred is not controversial. What raises alarm now is the combination of a weakening field, rapid movement of magnetic poles, and growing weak spots in the shield, all hinting that Earth's magnetosphere might be entering a state of flux. One striking observation is that the strength of the magnetic field has dropped on average by nearly 10% over the past 2 centuries, a marked decline in geological terms. While earlier estimates suggested a much slower decay, more recent satellite observations, especially from the swarm satellites, have revealed regional decreases and structural changes far more drastic and widespread than once believed. The field's dipole axis waxes and wanes. The North Magnetic Pole is wandering, in fact accelerating toward Siberia, and the so-called South Atlantic Anomaly, an area where the field dips dramatically lower than surrounding regions, is growing in size and intensity. All of this suggests that the dynamo deep beneath our feet is entering a phase of turbulence. This doesn't mean that tomorrow your compass will point south, but what scientists are increasingly convinced of is that the stability the magnetic field has enjoyed for tens of thousands of years may be slipping. If the field reverses as it has in the past, the most recent full reversal occurred about 780,000 years ago. The process would likely unfold over thousands of years, not hours or days. But during that drawn-out interval, there would be periods in which the field is greatly weakened. Stray magnetic poles pop up at unexpected latitudes, and protective shielding is diminished. Past reversals show magma flows recorded in lava and sediments, showing blobs of magnetic flux migrating, splitting, and merging as the dipole collapses and a new orientation emerges. Imagine the implications. Satellites unprotected by the usual geomagnetic barrier may be bombarded more heavily by energetic particles. The aurora borealis might blaze at far lower latitudes. Compasses may wander unpredictably. Navigation systems relying on magnetism may require frequent recalibration. Power grids and pipelines might face altered induction loads as cosmic ray flux increases. Migrating animals and sea creatures that rely on geomagnetism for orientation could be disoriented. And even deeper in time, the climate and biosphere may feel secondary effects from increased radiation or ozone shifts. The geophysical fault lines of habit are being shaken. A major part of the concern rests on the fact that the magnetic field isn't just weakening uniformly, instead, it is fragmenting. Studies of sedimentary cores and lava flows from past reversals show that the field doesn't just flip like a switch. It fidgets, fractures, and drifts. During the last reversal, for example, models suggest that multiple magnetic poles existed simultaneously, scattered across the globe, with the North Magnetic Pole wandering hundreds of kilometers and the overall field intensity falling to just 5 to 10% of its present strength in some places before the flip completed. The protective bubble shrinks, the planet's magnetic personality goes rogue, and during that interval, the world would have looked very different to creatures attuned to magnetic cues. Currently, one of the greatest signs of alarm is the gulf between what we are seeing and what we have come to expect. The North Magnetic Pole is moving at rates previously unseen, changing direction and speed. The South Atlantic Anomaly is growing not just in size, but in severity. such that satellites passing through it encounter higher radiation levels, and mission planners are already grappled with protective maneuvers. While researchers caution that these are not necessarily direct indicators of an imminent pole reversal, the pattern of behavior corresponds eerily with the early stages of past reversal events, when the field began to break down in localized regions. The Earth is whispering of a seismic magnetic change. One of the most remarkable implications lies in the timing and human-scale effects. A reversal of the magnetic field is not a headline event in the human lifetime sense, it is more of a creeping crisis. The field could linger in a weakened state for centuries or millennia, during which many of the normal protections we take for granted will erode. Navigation became more challenging. The geomagnetic compass, primitive tools that wildlife and humans use, may become unreliable. Radiation higher up in the atmosphere, and even down at ground level in rare cases, might increase. For a global civilization reliant on satellites, GPS, and magnetically guided systems, the stakes are high. In addition, there is the unknown factor of how Earth's interior dynamics will play out. The convective motion of molten metal in the outer core is inherently chaotic and unpredictable. Models show that once the field begins to break down beyond a certain threshold, recovery may either restore the original orientation or flip into the opposite polarity. The problem is that the threshold cannot be precisely predicted. Some forecasts suggest no reversal is imminent for another 10,000 years, while others caution that we may already be committing to a flip. We are, in essence, watching a slow-motion macro event where the planet's magnetic identity shifts while life goes on above. The historical record offers both comfort and caution. Reversals have happened many times, at least 183 over the last 83 million years, and life on Earth has survived them. But each reversal brought unique stresses. Some intervals of switching took only a few thousand years, others stretched much longer. For instance, the event about 780,000 years ago may have taken up to 22,000 years to complete. During those transitional phases, the field's intensity plummeted and the geometry changed dramatically. Recently, ice core and lava data show that when the dipole weakens, cosmogenic isotopes spike, hinting at greater cosmic ray penetration. The protective shield thins and flutters. What makes the current situation particularly unnerving is the convergence of multiple warning signs. The field's strength is dropping at one of the fastest measurable rates. The North Pole is migrating unpredictably, and anomalies in the magnetosphere are growing. These may not automatically spell the imminent commencement of a full reversal, but they raise the probability that Earth's magnetosphere is entering a transitional phase. And transitional phases are fraught. The safeguards that we built around steady geomagnetic conditions may no longer apply reliably. Our modern civilization may be more vulnerable in this phase than at any earlier time when humans roamed the planet. An important facet of this upheaval is the spatial shift in the field structure. The classic bar magnet metaphor of Earth's magnetic dipole, neatly aligned with the rotational axis, is breaking down. Instead, the magnetic field is fracturing into smaller, more chaotic patches. Beneath the surface, the molten metal core is producing streamers and lobes of magnetic flux that detach, twist, and migrate. One especially dramatic shift recently mapped involves two large flux patches in the core mantle boundary region under Canada and Siberia. Their interaction is believed to be driving the North Pole's sudden acceleration toward Siberia. The intact magnetic dipole is fraying at the edges, the core's engine is buckling, and the surface manifestation is wandering poles and messy lines of force. It is as if the planet's internal magnet is being rewired. As the field continues to unravel, electromagnetic shielding in the upper atmosphere and near space begins to falter. The magnetosphere's outer boundaries may shrink, exposing satellites and space vehicles to increased loads of solar and cosmic radiation. While Earth's atmosphere offers an additional buffer, the magnetosphere's defenses are first line. From a technological and strategic standpoint, this vulnerability is tangible. Satellite failures, communication interruptions, higher radiation dosage for high-altitude flights and space stations, and even perturbation of long-distance power grids via geomagnetically induced currents become more likely. In the glimpse of a reversal, our technological hood may lose its hood. For living creatures, the flickering magnetic scaffold presents junctures of uncertainty. Many species, birds, sea turtles, bacteria, sense magnetic fields and use them for navigation and migration. A disturbed field may scramble their internal compasses. With multiple magnetic poles wandering across latitudes, signals become scattered and confusing. Human-made navigation systems likewise depend on predictable magnetic references. If those references shift or invert, recalibration becomes mandatory on scales from personal devices to global shipping lanes. The loss of magnetically stable references would ripple through logistics, search and rescue, and transportation infrastructure. A deeper, less obvious repercussion involves our climate and atmosphere. While there is no direct proven causal link between magnetic reversals and mass extinctions, there is increasing data showing that when the field dips, atmospheric chemistry and radiation flows change. For example, during the brief excursion known as the Lachamps event, some 41,000 years ago, the magnetic field dropped to perhaps 5 to 25% of its normal strength, and researchers detected markers of increased radiation and ozone layer thinning. The subtle but broad-spectrum radiation increase could influence mutation rates, nutrient cycles, and even climate systems over long periods. At present, the field is nowhere near that depth of decline. Yet the trend downward prompts speculation. If the field continues to fade or deform, secondary atmospheric changes may follow. The red alert from scientists is less about immediate panic and more about urgent readiness. It is a call to bring geomagnetic anomalies, satellite operations, and navigation infrastructures into sharper focus. It is a reminder that the planet's deep engine is dynamic, and that human technological systems ride atop a magnetic shield that is not guaranteed. While there is no timetable for a flip, research suggests that once certain thresholds are crossed, lower intensity, multiple poles, fractured dipole, reversal becomes far more probable. And given that human lifetime spans are tiny relative to these geophysical timeframes, even a gradual flip counts as fast for civilization. In the background of everyday life, the Earth's magnetic field is changing, quietly and inexorably. As the molten metal dynamos adjust, the surface world may begin to register the subtle signs: compass divergences, increased auroras at low latitudes, satellite anomalies, rare bursts of cosmic radiation, and drift in navigation references. Over decades, we may see more frequent fluctuations, shifting patterns, and unforeseen disruptions. The trajectory of the field suggests that the next few centuries will be more unsettled than the last few millennia, as the magnetosphere wobbles and reconfigures. If a reversal is in the early stages, we could be entering a transitional era. The path ahead is not written in concrete because Earth's magnetic system is chaotic and sensitive to internal fluctuations. But the indicators are compelling: weakening field, wandering pole, expanding anomalies, historical precedent of reversal timeframes in tens of thousands of years. For humanity, this means preparation and adaptation rather than fear. Monitoring must intensify. Satellite and power networks must build in resilience, and navigation systems should develop contingency protocols. The planet's magnetic future is in flux, and the time to understand, plan, and adapt is now. The emergence of this red alert speaks to a deeper truth. Despite all our modern technologies, humans are still passengers on a planet whose vast internal workings we cannot fully predict. The magnetic dance beneath the crust, unseen yet essential, is shifting. What seemed like a fixture of the world for our lifetimes may become a relic of the past, and the state of the magnetic field our grandchildren inherit could be fundamentally different from the one our ancestors navigated by. In that sense, this moment is a hinge in geological time, one whose significance extends far beyond our daily awareness. As researchers deepen their exploration into the planet's magnetic mysteries, attention has turned toward the intricate choreography unfolding thousands of kilometers beneath our feet. Deep within Earth's outer core, molten iron currents churn and spiral in immense loops driven by heat escaping from the inner core and the planet's slow rotation. This convection generates electrical currents, which in turn sustain the magnetic field through a process known as the geodynamo. But the geodynamo is not a steady machine. It is alive, sensitive, and sometimes unstable. When its flow patterns alter, even subtly, the balance between north and south polarity can falter, leading to magnetic drift or full reversal. The patterns now being observed, lopsided flows, unexpected turbulence, and weakening dipoles, suggest the dynamo's rhythm is faltering in ways that challenge existing models. The scientific instruments tracking these fluctuations have reached an unprecedented level of precision. From orbit, the European Space Agency's Swarm satellite constellation constantly maps variations in the magnetic field, producing a global portrait of its strength and direction. Beneath Antarctica and the South Atlantic, sensors detect eddies of magnetic change, each one a symptom of deep core flux migrations. The data show that the alterations are neither random nor isolated. They form a coherent narrative of a planet adjusting its internal circuitry. Even subtle fluctuations in core temperature or rotation speed can propagate outward, creating surface anomalies thousands of kilometers away. The Earth, in essence, is communicating through magnetism, and the message scientists are decoding is one of transition. What fascinates researchers most is the complexity of that transition. Earlier generations of scientists once imagined magnetic reversals as simple flips, a north becoming south in an elegant switch. But new evidence reveals that the process is much more chaotic. Magnetic north may splinter into multiple poles before reforming. Temporary poles can appear at the equator or near the tropics, linger for centuries, then vanish as the dominant polarity reasserts itself elsewhere. During this time, the field's structure becomes almost patchwork, a lattice of competing domains. Mapping these ghostly fields is like charting invisible weather systems swirling through the planet's core, constantly evolving in response to unseen currents. The modern red alert arises not from the inevitability of change, but from our incomplete understanding of how that change will manifest and how fast it might progress. These revelations have inspired an interdisciplinary surge across geophysics, atmospheric science, and technology. Understanding how a shifting field influences Earth's radiation belts or the ionosphere has become critical for everything from weather forecasting to telecommunications. Engineers are re-evaluating spacecraft shielding, anticipating that the weakening magnetosphere may expose electronics to new levels of radiation. Pilots and navigators are training for recalibrations as aeronautical maps update to follow the pole's relentless march northward. In high-latitude regions, communities accustomed to using the magnetic north for orientation must now rely increasingly on true north references, a subtle but symbolic adaptation to a changing planet. Meanwhile, the psychological dimension of this cosmic drama cannot be ignored. Humanity has long associated the magnetic poles with stability and direction, literal and metaphorical. The compass needle has guided explorers, travelers, and civilizations for centuries, embodying the sense of order that magnetism provides. To witness that order eroding unsettles something deep in the collective psyche. It reminds us that even the most fundamental reference points of our world are impermanent. The North Star may remain fixed in the heavens, but the magnetic north beneath our feet is on the move, and its restlessness echoes the dynamic, ever-changing nature of the planet itself. The red alert is thus both a scientific and philosophical reckoning. It signals that Earth's inner engine is in flux, reshaping the shield that has cocooned life for eons. It reminds us that the magnetic field, though invisible, is one of the most vital and volatile systems on which existence depends. As researchers continue to probe the molten darkness of the core, they are not merely studying magnetism, they are tracing the pulse of the living planet itself, a pulse that is now quickening, shifting, and hinting at a transformation written in the language of iron and fire. The present observations unfolding in geomagnetic science mark one of the most significant natural phenomena humanity has ever monitored in real time. What makes this moment especially consequential is the convergence of ancient geological processes with the vulnerabilities of a highly technological civilization. The field that once seemed like a silent constant is now revealing itself as a restless entity, and every new measurement offers a glimpse into a world on the brink of magnetic metamorphosis. This evolution of the magnetic field serves as a reminder that Earth is not static. It breathes, pulses, and reorganizes from the inside out. Geophysicists are increasingly focused on the microdynamics within the outer core, using supercomputers to simulate fluid interactions under immense pressure and heat. These simulations attempt to replicate the turbulence that gives rise to magnetic polarity, and the findings are striking. Small perturbations in core convection can cascade into major magnetic reorganizations, demonstrating how sensitive the field is to thermal asymmetry. In a way, The planet behaves like a living organism, its heartbeat irregular, its magnetic pulse now quickening. The red alert issued by scientists is therefore not a prediction of catastrophe, but a recognition of profound planetary movement. Humanity stands as witness to an unfolding geophysical chapter, one that underscores how deeply our fate is intertwined with the invisible forces generated by the molten heart of our world. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Earth's magnetic field starting to reverse soon? We want to hear from you. Thank you for watching and see you next time.